Good morning, everyone, and thank you for joining us this morning for the second in a two-part series focused on driving sustainable value through LinuxONE. Today, we're going to be focusing on, we learned all about the underlying hardware technologies on Tuesday, and today we're going to be focusing on really the use cases and the value proposition. My name is Susanne Woods, and I'm the Chief Growth Officer at Evolving Solutions. With me today is Monte Bauman, and Monte is a LinuxONE solution architect at IBM. Monte spent the last 39 or so years of his career with IBM helping clients simplify technology. But in his current role as a LinuxONE solution architect, he works with clients to develop solutions to mitigate risk, but also be sustainable. Before we get to Monte, though, I would like to do a brief introduction of Evolving Solutions, just for those of you who don't know us. Our company was started over 27 years ago by Jamie Gamach, our CEO and founder. We are headquartered in Minneapolis, Minnesota, with primarily a Midwestern presence. However, we do have some very large clients with both national and international presence. As I'm sure many of you will attest to, technology has changed substantially over the last 27 years. And to continue to support the growth of the business, more and more demands are being placed on IT organizations to be more flexible, more secure, faster. We work with our clients to simplify technology by modernizing and automating IT operations. You know, the world has changed substantially over the last many years. We all have seen it, and I think it will continue to change. That makes businesses more unpredictable. And in this unpredictable world, IT organizations need to be flexible to take advantage of new technologies and new consumption models. We call this modern operations. You still need to deliver the same level of stability and security you always have, but in a very different and new world. At the core of this lies the platforms, that circle in the middle. And the platforms today are far more complex than they have been in many years. No longer do platforms live in the four walls of a data center, but you now have cloud, multiple clouds, and a hybrid cloud world that you have to support. We work with our clients to simplify the technology in this space, the platforms, while building sustainable solutions. All the things that Monte talked about last Tuesday, but also will continue to talk about today. As you go around the circle, you will see the areas that we have invested in and we have built some skills in addition to our platform skills. First and foremost, data access and connectivity, ensuring that people have access to the data they need, but more importantly, they don't have access to the data they shouldn't have access to. Through segmentation, SASE, all sorts of new technologies, we work with our clients to not only build strategies, but also implement solutions to help support that environment. Observability. Observability is really having the ability to anticipate an impact to an end user experience before it actually ever happens, and in an end-to-end fashion. We work with our clients that tell us they have lots of tools to monitor and manage, but really the question is, can you do this in an end-to-end fashion and have that expectation to anticipate before an event actually occur? Data protection is probably the area that has changed the most over the past many years, and I think it will continue to change. Just because you move your data to the cloud does not mean that it is secure. We leverage the experience we gained in the four walls of the data center to build data protection strategies, and we've added some talent and experience in building those strategies out and helping our clients implement solutions to protect their data in this new complex world. Last but not least, pipelines and automation. This is really all about making it easier for those developers to consume underlying technology infrastructure. By automating your operational processes, this is how you avoid shadow IT. I can talk about this for hours. However, we're not here to do that today. You guys are all here to hear from Monte. So without further ado, I'm going to hand over the mic to Monte, and then I'll circle back at the end. Monte, it's all yours.
Excellent. Thank you, Susanna, this is indeed Monte Bauman. Hopefully my sound and screen are coming across clearly. I do look forward to the next 45 minutes or so as we dig into LinuxONE's value proposition via the use cases, the software that are afforded by the platform. But just to overlap a little bit from last session, we started with this picture and really with an overview of what we're going to talk about, which is how LinuxONE is defined as hardware, and we'll cover that very briefly today, just as a catch-up. But we're really going to jump into the software and the ecosystem so that we can explain and express how we get better operations, we get mitigated risk, and we get lower costs delivered via use of the LinuxONE platform. We're driving hybrid scale, hybrid cloud at scale. We're driving decision velocity with the AI capabilities that we will review and build out. Cybersecurity is awfully important, and sustainability. Everybody, and rightly so, is working on sustainability strategies. Carbon sensitivity is at a peak. So we're taking a lot of calls, a lot of work going on just how to become a more responsible citizen. So the platform's been built. We've got drivers that are built by audit and compliance, and so the platform's been built over the 20 years or so to be an extremely robust deliverer of Linux computational capabilities. The cores, be it the Z15 core, the Z16 core, are really very, very powerful cores that when you build out the modules, you build out the Emperor 4, which was announced a couple months ago. It's just extremely powerful technology that we can virtualize with extremely flexible virtualization structures. And then if you put on top of those virtualization structures, Cloud Infrastructure Center, you get infrastructure as a service automation, Terraform and Ansible automation. You get some terrific, underpinnings of capabilities that are unlike any server in the world. So we can consolidate and we can save money, we can drive value, which really brings us to this point today of driving and talking about the flexibility and the use cases and the value proposition. I pondered how do you boil down all the use cases into a single picture, and this was the picture I came up with. So if you like it, I hope you like it. There's kind of a lot to unpack here. So going out around the edges of this are the classes of use cases. And so certainly application serving and database serving have been the core of computation. Transactions and batch and process over here, data serving, files and databases over here. And as soon as you have a bunch of applications and a bunch of databases, you want to integrate them and you want to do some messaging, event flows over here. This has been kind of the cornerstone of computation and the cornerstone of use cases built out on LinuxONE, characterized by software like Oracle as a database, like WebSphere as an application server, like MQ as an application integration layer. But you'll see sprinkled in here is more and more open source. So as the 20 years of Linux have evolved, open source has evolved as well. And open source, and I think everybody's using open source in serious ways these days. So MQ and Kafka can integrate and can interplay and can be integration layers. And we move to more and more event-based programming. Kafka is an example of an open source title that is really powerful and popular in those use cases. Where folks want to stop using Oracle as a vendor-provided database and use something that's quite similar, Postgres comes to play as an open source database that's built and modeled around all the things that Oracle does and how Oracle works. Even the stored procedure engine of Oracle is modeled and built into Postgres. As WebSphere has moved on and the open source world has moved forward in application servers around Java, the Tomcat space, and lots of others are in that space. As we move around the pyramid, as we move around the circle here, we get to some other emerging use cases, if you will. And one's kind of a natural one. As soon as there's a bunch of data in place, be it files or databases, and I should mention that these databases are no longer simply and only SQL databases. NoSQL has grown up and is extremely popular in the driven out of the open source world. So MongoDB, as an example of one of many NoSQL databases, is very popular title on the platform. And so those data, when you start to accumulate that operational data and you start to climb the AI ladder where you turn data into information, you turn information into insight, and you turn insight into decisions. Well, that's this AI ladder, as I like to think of it, and those capabilities, whether it's TensorFlow, PyTorch, and other tools and technologies, are available on the platform. And the new deployment models, application integration, data integration. We're going to talk about Kubernetes. We're going to talk about new Kubernetes form factors like Rancher, like Openshift from Red Hat, all available on this platform to build out not just and to garner more and more software onto the platform and to be able to build software in more sophisticated fashions and to be able to deploy the more available software in easier manners. So we'll talk about the hybrid cloud, the native cloud, and OpenShift and Kubernetes. Last week, we did talk about the hardware layers of trusted and confidential computing. So that's where the most demanding of software sits down on that most needful security layers of hardware. That's typically in the digital asset custody space. And blockchain is an example of code that sits and basically is an example of code that encrypts everything. And then it encrypts that encryption, and then it encrypts the data. So it depends wholly and solely on transactionality that is end-to-end encrypted in fashions that are trusted execution environment based computing. So this platform, unlike any other platform, can deliver that kind of environment at a scale point, at a point where you can actually scale those transactions up while maintaining that level of security and robustness. What this all means when it's taken together is when we get to the server consolidation. And we mentioned this last Tuesday, where we have consolidation ratios, where folks have taken and consolidated volumes of Oracle databases, volumes of Webster application servers, volumes of MQ servers. When you take a bunch of small, maybe low utilized virtual servers on x86, and you consolidate those, you move that middleware, and middleware of those ilk move very easily. When you move that work and move that middleware and consolidate onto a single vertically scaling capable server like a LinuxONE server, you can end up consolidating cores, and what took 500 x86 cores now takes 50 LinuxONE cores, and the simplification in terms of infrastructure, the simplification in terms of your software bill, the simplification in terms of your energy bill, your floor space bill. You get a lot of downstream benefits from that simplification and that consolidation of services, which really comes back to the sustainability story. Some of you out there may have ZOS and the LinuxONE, the LinuxONE side of this machine. There's a ton of new tools and capabilities that have been built out in the last year or two, particularly with the Red Hat acquisition and Red Hat applied tooling and what they used to call code-ready workspaces, basically browser-based IDEs, and understand and analyze tooling for code modernization and understanding. It's really cool that we can put those capabilities essentially next door to the ZOS systems and LinuxONE systems, and it provides better integration, better security, and those co-location and latency issues can be a real big advantage. So this is in a nutshell, a lot of what the use cases on the platform are about, and we see in the yellow bubbles kind of that tie back to the hardware capabilities of the machine, tying to this new software view of the machine. The Java acceleration that is really, really helpful in terms of application integration. The compression acceleration that really helps managing and keeping data under control as it tends to explode in this digital world. Sort acceleration, AI acceleration is really key to driving insights. If we're going to do build insight and make decisions at volume, well, we're going to need some inferencing acceleration capability to do that, so we don't blow up the transaction budget of every business process we're running. If we're running trusted and we're running trusted execution environments, we need that hypervisor support. We need that hardware support. We need that crypto support so that we can accelerate and execute encryption algorithms at volume, at speed. And if we're going to co-locate, we're going to enjoy cloud native deployment of applications on the edge that want to come back to systems of record or data of record. Then the low latency shared memory communication capability that we'll talk about soon are going to be really important, the network acceleration layers. So that's so this story, there's a whole lot to unpack here, and hopefully I unpacked it appropriately, and hopefully that's an interesting way of consolidating the story in a nutshell. Open source is awfully important, so I wanted to comment on just how important open source is and where it's at. The ecosystem team of IBM was organized when we built out the LinuxONE brand in 2015, and we've really invested more and more in the time, more and more energy, time, space, and resources in bringing software to the platform, supporting open source providers, supporting independent software vendor providers as well. In this chart, though it looks very busy, it's kind of a fun, I don't know who built the chart. It must have been fun finding all these logos, putting them together. It really, but it illustrates that the notion that we've got a lot of the core important enterprise-ish software available on the platform. And the list is growing. There's links down here that we could provide all who want to find or more readily find the sources of the software information. And the key thing that's bringing more software to the platform than ever is the Openshift movement, the Kubernetes movement, the container image movement. When we acquired Red Hat about 2 years ago, 2019, maybe that's 3 years ago, we jumped in the container image space, and software providers have been moving towards and jumping into the container image space as well. So to the degree that more and more folks are working in the container image space, and more folks are seeing and readily building out multi-architecture container images, which is really one of the coolest aspects of container image technology, is the ability to build a binary and run a multi-pipeline build process that will build the x86 binaries, build the power binaries for a power chip, build the Z binaries for a Z chip, build all those binaries simultaneously, package them into a container image file, and then house that. And then if you're going to embed that software in your program, then the build processes know which architecture you're building for, and it pulls the appropriate image binaries from the multi-architecture image file, and it facilitates greatly that whole process. It also facilitates the movement of code that otherwise might not have come to Z. So when we first introduced Openshift and first pushed it onto the Z platform, there was a couple hundred container images instantly available. A couple years later, that number's up into the thousands. So we see a nice movement, and it's really advantaging that fact that, pretend you're a software provider. You would like to write software for the volume world of x86, but you hate missing those niche world of high-end Linux on Z and that high-end compute world of power. So if you want to be a multifaceted, broadly available piece of software, you want to pick technology and a runtime that supports your ability to deliver your software how it needs to be run, and deliver that choice to your clients to run your software in a fashion that makes sense to them. And by and large, that's Openshift's value proposition. It's built out to be a runtime that can be on-prem, on Z, LinuxONE, Power, but it's also built out to be available in the cloud and the various public cloud form factors, the IBM Cloud form factors. There's even versions of Openshift for edge compute, for IoT compute. So Openshift is a Kubernetes bundled, sophisticated, very, very clever piece of code that has this multi-factor deployment capability. And we're really happy and really pleased with just how well it runs on Z. And it's really no surprise that it runs so well on Z. If I were to look at an Openshift configuration, let me just shift to that real quick. You can't see that Kubernetes, which is under the covers of Openshift, is this multi-region kind of thing. There's processes that do control. Sometimes these are called control nodes or master nodes. And then there's processes that run apps. And these are usually called worker nodes or compute nodes. And if you harken back to CICS, MRO, or mainframe computing of the 80s, as we evolved into multi-address space operations, this is similar. Computer science is computer science, and And the distributed world, the open world, stood on the shoulders of the predecessors in that space, and they built out a construct that's very, very clever. It's multinodal. It recognizes the fact that the hardware it may be running on may not be all that resilient, and as such, you can split the master nodes across different form factors and across different servers that are less resilient than others, and kind of just use clustering to solve a lot of nodal hardware problems. So the other aspect of this is scale. So as you deploy worker nodes, you can deploy two, as is drawn here in this simple picture, but you can deploy and vertically scale these worker nodes, so you can put more work in a node if your server supports that. Or you can split your work horizontally if the work supports that, and create more and more worker nodes. And whether those are deployed to 1, 2, or 3 or more servers, that's a flexibility that Kubernetes and Openshift provides. So sophisticated, smart, multi-architecture container runtime. And we enjoy it very much on our platform. And indeed, we've got use cases and proof points where we're running millions of containers on a single LinuxONE server, which shouldn't be too big a surprise. I mean, if you look at the ZOS world, we run millions of processes, millions of transactions and batch jobs on a single server. Well, this is the same kind of compute in a computer science perspective, just wrap it into a new form factor that is Kubernetes. But the hardware enjoys this kind of compute model, and the hardware thrives under the duress of this multi-region kind of operations. So it's a really good story. OpenShift adoption has been really good on the platform, and it's really been broadly adopted across industries from credit cards to automotive to retail. And use cases include co-location, as we've talked about. If you want to put cloud native computing next to ZOS or other core systems, that's where co-location can be really a cool space. A lot of the modernization tooling of ZOS and modernization of just going towards cloud native capabilities is available through tools and tooling on OpenShift. So there's data, AI. There's a lot of I'm not going to give you an OpenShift pitch. I'm concentrating on LinuxONE overall, but this is hopefully gives you some food for thought. Perhaps you find your industry, or you find your problem space defined here as a solution space, and we could work together on that. If you're running really interesting applications in OpenShift, you'll need a persistent data layer. And by interesting applications, I mean stateful applications, applications that share state and store state and really write to a persistent storage. And by that, we mean enable the ability to move that stateful application from node to node, because it's now got a persistent storage mechanism underneath the covers. So that provides resilience, it provides ability to move work, role change, and do things of that nature in an enterprise sense. It's important. So NFS is built into OpenShift, and it's very functional. It just doesn't scale real well. So there's two choices. There's the OpenShift Data Foundation from Red Hat, which is a much more scalable, much more capable, supports many more APIs and file constructs, data constructs. But then good old IBM Spectrum Scale is also a great choice, particularly if scale is a requirement. So it's terrific having those choices, terrific having a persistent storage layer and capability. So OpenShift configs that I mentioned earlier, it's kind of fun to remember the partitioning capability, the virtualization capability we talked a little bit about last time. And this illustrates how you can get started with OpenShift with a single partition. Here I've drawn it as a KVM partition. And here's a virtual machines under KVM. 3 of them over here for the control nodes, a couple over here for worker nodes. So in a single partition with a fair, not a ton of resources, you can start to build out and play with OpenShift. If you evolve OpenShift, we typically look to evolve it into multiple partitions. So here I've drawn ZVM partitions, but we've got 3 partitions that could be on the same server, and now they're splitting and distributing that work across those partitions, and they've distributed the control plane across those partitions. So now we have resilience across the partition level. Of course, if we want even more resilience, we want to use more servers. We may have those 3 partitions across 3 different servers, and now we're getting tremendous resilience and tremendous scalability through an OpenShift deployment on the platform. So there's a ton of capability. And if you think about IBM's own movement to OpenShift, And by that, I mean IBM's now delivering the bulk of our software portfolio onto the Openshift form factor via container image based build and deploy. So IBM's seen the value of container images, and we've moved our portfolio in that direction. And we picked Kubernetes and we picked Openshift as the runtime. So we bundled the software that has to do with data into an IBM Cloud Pack for data. We bundled software that has to do with business automation, business process and decision support kinds of software into business automation Cloud Pack. The Cloud Pack for integration has to do with APIs, API management, API managers, integration, message integration, and there's even third-party and open source software in our Cloud Pack. So MQ you would find in here, but you'd also find Kafka stuff in here. So it's a clever packaging, and again, it sits on the OpenShift foundation, and it brings to the Z and LinuxONE platforms the IBM portfolio through via this Cloud Pack delivery mechanism and the Kubernetes runtime underneath it. So I think it's a terrific story overall. It builds out nicely, and it sort of builds out the future as we look to see and enjoy more and more container-based builds and more OpenShift-based deployments. This chart, for those of you who are running ZOS, will be an interesting piece. So if you're not running ZOS, I apologize. I'll be brief. But there's an awful lot of really important software running in the ZOS world on Z hardware, and that's what this right-hand piece of the ball is of this drawing. We've got JES I'm representing, CICS, IMS. So these are the apps and transactional and process-based applications. This kind of an application layer. And over here in purple, I have vSAN, I have IMS database, I have the DB2 for ZOS database. So in purple, I kind of have these data representations of files and segments and tables. So that's kind of system of record transactions, system of record data. But we may want to get to that data in new and interesting ways. And one of those is through the modernization of capabilities afforded by REST and REST APIs, and by ZOS Connect as an enabler and a handler of REST APIs. It basically is a front door to ZOS for acceptance of REST-based API requests, and a mapper of those API requests, those REST-based API requests, into the lingo that backend systems understand. So ZOS Connect has easy linkages that can be built to CICS, for instance, or IMS, and so we can readily web enable, a CICS transaction or an IMS transaction, API enable that transaction, create microservices, architectures, API enable, API catalog that API, manage and control that API, secure that API through API management. But let ZOS Connect be the fundamental generator and handler of those API requests. We can accept API requests through ZOS Connect, and we can also generate and build outbound API requests. So CICS can generate a REST-based call and move through ZOS Connect out into the internet world. Say, I always think this is a funny example. Say an accident occurs, a claim is generated, and we want to just see what the weather was like when that accident occurred. Well, we could make an API request of a weather service, give it the parameters, that GPS location, that time and date, and get back what the weather was like. It's a simple example of making an outbound request. So as we do claims management, we have that little bit of data, and we can do that much smarter a bit of work through a fairly simple outbound request. So ZOS Connect enables that, and it's a terrific piece of technology. It's been adopted like crazy. And now ZOS Connect can actually run as a ZOS address space. It can also run in this LinuxONE space as a Linux or LinuxONE space. So it's very flexible in its deployment mechanism as well as its execution mechanism. The Data Virtualization Manager is a similar piece of software that's worth talking about just briefly, and that is it API enables the access to backend data. And it also sort of is just as ZOS Connect mapped form factors, DVM, Data Virtualization Manager, can map form factors too. And by that I mean simple example would be a NoSQL API call coming into Data Virtualization Manager, and then Data Virtualization Manager mapping that NoSQL call into a vSAM record call. So it's in a sense a way to turn vSAM into a NoSQL database by pointing those Mongo APIs at vSAM, and it works really, really well. vSAM runs very, very fast, and it's a simple way to enable in a modern fashion applications that you want to build out in your new cloud native fashion, but still hit in modern ways your backend data. So very, very clever capabilities. And then in the modernization space, here's where some new code has been delivered in the last year or so. The ZOS Connect Designer can run as a LinuxONE tool. WASI Analyzer, WASI Sandbox, WASI Code, these are all kind of modernization of Z capabilities. Develop and change code that's COBOL or other code on the mainframe. Build a sandbox where you can test that code and then build and have an analyzer environment that scarfs up that code, scarfs up the metadata around that code to help you understand code flow, data flow, and the like, so that you can then develop and change code faster to meet requirements and build new systems. So these are all new modernization elements. They're all part of what is called the IBM Z Cloud Modernization Stack, all deployable to this environment that I've alluded to that could be powered by IFLs on the hardware platform that is LinuxONE or Linux on Z partitions. And the final remark I'll make is this layer underneath, which is the ability to link this partition and this partition together through shared memory communications, through this improved, faster means of communicating. It could be through the firmware layer. If this LPAR and this LPAR are on the same hardware, then it's shared memory communications direct. It's really just a firmware-based network. If it's partitions on different technologies, different servers, this partition's on one server and this partition is on another server, then we'd be using shared memory communications remote, which is RDMA, Rocky protocols over direct memory access protocols over converged Ethernet networks. So it's kind of a fast path through the TCP/IP stack. And even though we're using the same wire, same NICs, we're using the Rocky NICs, the Rocky technology. It uses the same wires we're used to seeing and the same switches, but it just runs an accelerated TCP/IP stack. So it's a fairly easy transition, and the benefits are terrific. So that's something of a roundup on the use cases and software. And I'm going to conclude this talk with just coming back to the value proposition. And we talked a bit on Tuesday, quite a bit about the hardware, its performance and throughput capabilities, and its hardware-software synergies. Today we've talked about the software, and we talked a good deal about how it can drive lower costs from server consolidation perspective, improve capabilities in the cybersecurity and decision velocity space by picking things like TensorFlow, picking things like Openshift, and the security space. So I'm going to kind of go around this circle just a little bit and zero in on a few final things that are worth thinking about. And one is, and I've boxed up a few of some of these things to help me point out that the latest generation of Z16 chip brought some new security and compliance capabilities. We've, for the longest time on LinuxONE, provided really high performance protected key technology. We've provided master key encryption capabilities in a hardware storage manager that's unlike any other hardware storage manager. It meets the highest levels of capabilities. But now in the Z16 based technology, the Emperor 4 or Z16s, we actually have system-wide encrypted RAIN. There's the memory in our RAMs, it doesn't appear in unencrypted form anywhere, anytime, any place. It's encrypted. And by the system, it's only decrypted when it comes across the RAMs into memory buffers, into the registers, essentially, into the caches and into the registers of the cores. So it's extremely secure. So again, just closing each and every threat aperture that we can and this one closes a big one. Quantum safe cryptography, as we've been doing crypto for the longest time on the platform. These are just new algorithms that are available on the crypto chips in the CPACF facility, and these encryption algorithms are unfriendly to quantum algorithms. So these algorithms, these new encryption algorithms, are safe or against future quantum attacks. So it's our suggestion that all enterprises that want to be safe from future quantum capabilities, because essentially quantum is getting more and more real. Quantum is becoming, is essentially equal in some ways to digital computing. So it won't be too long before quantum computing can start to do things that digital computing cannot, including decrypting and cracking encryption algorithms that aren't quantum safe. So this is why we want and encourage the move towards quantum safe cryptography, and using the quantum safe cryptography algorithms that are hardware accelerated makes every bit of sense. The other piece of new technology that was announced with the Z16 and Emperor 4s was the IBM Z Audit and Compliance Center. So we see here how data breaches are important to avoid because they cause downtime. We see that IBM Z and LinuxONE have done a really nice job of avoiding downtime associated with breaches. Other platforms, not so much. But even this, we're unhappy with. So IBM came out with a Security and Compliance Center to help drive down these breach-based outages by assuring that all configuration parameters, everything we can do to be NIST compliant or to be PCI DSS compliant, to assure that we are doing them. So it's essentially, if you're a ZOS guy and you know health checker, have health checkers, it's in a sense a very smart health checking environment. It basically checks each and every PCI DSS criteria against a ZOS configuration parameter, or a LinuxONE configuration parameter, or a ZVM parameter, or a KVM parameter. Based upon how you built your system, this tool supports ZOS configurations as well as LinuxONE configurations, as well as LinuxONE configurations. Essentially gives you a scorecard, kind of a dashboard. It weighs each regulatory measure against your configuration. It says green where you're good to go, where you've done the best practice. It shows yellow where things are not as maybe as good as they could be. It shows red where it's unclear or it's simply not complete. And this helps you to get NIST compliant, get PCI compliant, and further helps you maintain your audit readiness. So that scorecard is a dynamic scorecard. It doesn't just do it once a year and say, "Yep, good to go, and run me again next year." No, it's a constant scorecard showing you where you're at any given time. And when it does become time for an audit, you could obviously see how this could reduce your audit preparation time from months to weeks, or to less than a week. So it has a tremendous ability to build reports that can be pulled and then given to your auditors who are doing your PCI audit compliance or NIST audit compliance. Other regulatory bodies are coming. So PCI and NIST were the first, but others I think already have, and others are in plan. And there's a interface that lets you do your own kind of health checks under the covers. If you're not PCI, you're not NIST, but you have your own standards, you could actually build this out and it'll support that. So we're driving the risk and mitigation capabilities of the machine quite readily and heavily. On this side of the machine, the risk is driven down by unplanned outages, and planned outages driving all outages towards zero. And you can see from these guys are pretty sure they make it look like we've driven them all out, and of course that's great. This is a report that shows tremendous uptime from a Z and LinuxONE and LinuxONE perspective. Other platforms not so great, but even as we're this good, we haven't taken the foot off the gas pedal. We're continuing to drive And we're up to what we think is 7 nines. We're up to basically a century of mean time between failures, statistically speaking. So it's terrific technology, and the Z16 based and Emperor 4 based technology continue to build out that technology. The final, I think, piece of this pie is the cost pie. So the cost of get rid of these things. The cost of IT. So we want to use Linux for reduce the cost of charges to software vendors, reduce the cost of charges to energy providers. We've talked about that a fair amount, and we've talked about how server consolidation really does work. There's tons of server consolidation examples. We've seen, and the average is a 13.6 to 1 core consolidation ratio. Those ratios vary, and your mileage will vary. So if you want to ask me what your ratio is going to be, I'm going to say it depends. But we can figure that out. We can work through that. But generally speaking, we see x86 servers consolidating onto Linux One servers, and energy consumption going down by something like 75%. Data space, floor space in your data centers reduced by something like 50%. So the potential value is really high, and the migration efforts not necessarily difficult, particularly if they're middleware-oriented applications that we're working on. This final example, and I'll conclude on this example, is a server consolidation, open source, really does a little bit of everything we've just talked about. And this was awarded by Mongo, and it's based on MongoDB as a NoSQL database, and based upon a very large enterprise, that enterprise being Citigroup, the building and Mongo as a service delivery mechanism out of their IT group to supply Mongo as a service to their IT users. So they picked Linux One, and they deployed several Linux One servers and many IFLs, cores to the work. And in so doing, they improved the performance of Mongo for their users. They improved the deployment experience of Mongo for their users. They deploy, and at the end of the day, the IT group is enjoying less energy consumption, less floor space consumption for the same amount of Mongo work being done when compared to x86. And the other key part of this is the security piece. So using our encryption technology, they've closed threat apertures around the security of that Mongo database data. And by using the flash systems arrays attached to the Linux One servers and using IBM safeguarded copy, they provided ransomware protection that meets FFIEC Appendix 3 requirements in this financial space, unlike any fashion that they could have dreamed of. They basically get ransomware recoveries abilities that are seconds in duration rather than the previous technology in use, which was months of wait time to get a ransomware attack recovery instituted. So there's been a really broad brush and award-winning solution for the sustainability, for the performance, for the lower cost, and for the security and ransomware protection. So it was really a really good end-to-end Linux One success story, and one of the most demanding IT environments in the world, one of the most demanding of IT consumers in the world. So terrific story end to end, and hopefully that kind of wraps up the Linux One value proposition and helps you all understand where the platform's at, where it's going, and what it might be able to do for you. So I'm going to pass the ball back to Susanna. Hopefully my timing's okay, and we can if I could be of help, do let me know.
Monte, thank you very much. Very insightful. So I am walking away from this with an extremely scalable, secure, highly available platform, fast, in a smaller footprint with lots of open source and other solutions available. And that will help you reduce your carbon footprint, hence the sustainability. I thought I'd just share, just this morning in my inbox, I got a quick email from the IBM Institute of Business Value, and the COP27 conference on climate change is actually kicking off in Egypt later this month. IBM published a paper. It's called The 5 Steps to Accelerate Sustainable Transformation. So you can find that on the IBM Institute for Business Value site in case you're interested. So with that, I would like to just remind you that you can contact any of us, Monte, myself, or Scott Radine. Scott is our IBM LinuxONE sales specialist here at Evolving Solutions, with any comments or questions you may have. So with that, I appreciate all of you joining us. Monte, thank you again for participating in our 2-part series of webinars, and enjoy the rest of your day. Thank you.